Alrighty, so we will get started today. We just want to welcome everyone to our science show this week. We're super excited that everyone is here. So we invite you to turn on your cameras if you wish, just so we can see your smiles. Anyways, yeah, we're super excited to see everyone today, and we hope that you guys enjoy the show. So I'm going to pass it off to one of our instructors. So Alexandra is going to start us off today, okay?
Hi everyone, my name is Alexandra and I'm one of the instructors at Superior Science. I'm going to share my screen right now and I'm going to teach you a little bit about tornadoes. Today's show is all about different kinds of weather. Bella, if you could just let me share my screen. Awesome. All right, let's get this started. Perfect. So all about tornadoes. And this is a picture of a tornado, actually a tornado in Canada, which happened in Manitoba in 2007. And it's the most powerful tornado that's ever happened in Canadian history in 2007. Super cool. And you might know tornadoes by a few other names, twisters or cyclones or funnels. So what is a tornado? You might know to see one, but it's one of the most violent types of weather, and it's a fast rotating column of air. Now you might be wondering, how do tornadoes form or why do they happen? Well, they start from a special type of cloud called cumulonimbus clouds. Very long word, but essentially this kind of cloud is a thunderstorm cloud. Now, how these happen is when the wind direction in the sky and the speed changes really high up in the air, this causes the air to start swirling horizontally like this. And then the air from the ground, the warm air from the ground pushes up onto the swirling air in the sky, which makes that swirl kind of tip over, which is why we sometimes see tornadoes on their side. And the warm air from the ground continues to be sucked up, and that funnel shape grows longer and it stretches towards the ground. And at the point where it touches the ground, that's when we can call it a tornado, once it's touched the ground. Now, a few characteristics of tornadoes. They can really be all different sizes, but usually they're about 500 feet across. Now, the winds in tornadoes, obviously very dangerous, can range anywhere from 100 to more than 400 kilometers per hour. So we drive about 90 or 100 kilometers on the highway in a car, so you can just imagine how fast the wind is moving. And tornadoes can be all sorts of different colors. They can be almost invisible, like the color, like the air, or depending on what kind of materials that they pick up along the way, they can be all sorts of different colors. Now, to measure the strength of a not a volcano, a tornado, they use something called the enhanced Fujita scale. And they started using this in 2007. And rather than just looking at the wind speed, scientists can take an estimate of the wind speed and the strength of the tornado by looking at all the damage that the tornado has caused. So these lower intensity tornadoes might do some damage to gutters or the siding of houses, but wouldn't be enough to pick anything up off the ground. Whereas a super severe tornado, there might be houses swept off the ground, and these can be a lot more dangerous. This is a map of the United States, and I wanted just to mention this briefly because there's something here. That red area is called the Tornado Alley, and that's where most of the tornadoes take place in the United States. And they usually happen in the late spring because that's when all the conditions are perfect to make a tornado. And all of these different areas of the warm air and warm moist air and cold dry air meet, and that's what creates the perfect conditions for these tornadoes. And in some of these regions in Kansas and Oklahoma where there's the most where there are the most tornadoes, sometimes the building requirements, or if you were building a new house, they have really strict rules as to how you have to build your house, because they want to prevent damage, and they know that there's going to be tornadoes. So they need to be really sure that all the houses are safe. So now I'm going to stop sharing my screen and show you a fun way that you can simulate a tornado at home. All right, maybe I'll pin. I'm not sure if Bella, if you can pin my screen right now. Perfect, awesome. So what I have here, and it's already made, so I'll explain how it was made. This is a special tornado twister. And what you do is you take 2 pop bottles, and one of them you're going to leave empty, and then the other one you're going to fill about 3/4 of the way, 2/3 to 3/4 of the way full with water. And then I have a special connector piece in the middle, but you can use duct tape at home and a washer or something else that's going to keep it really tight. And in this, we can see a vortex forming in a minute. And what a vortex is it's liquids and gases that travel in a spiral around a central line, kind of like we see in a tornado. So I'm going to show you how it works. What I'm going to do is flip it upside down and spin it. And if everything goes according to plan, we should see something like a tornado forming. I'm going to spin it around a few times. And we can see, I'm not sure if you can see that, there's a tornado or a vortex that's forming in the bottle. And it sucks all of the material, it's pouring all of that water into the bottle below. Now, how does this work? Well, the gravity is pulling the water through this space, this hole in the middle. And if we were to just flip the bottle over without spinning it, we're going to hear that glug, glug, glug sound. I don't know if you can hear it, but it takes a really long time for this bottle to fill up. And that's because the water and the air in the bottle have to take turns going through this middle part. But when we do that, I'll do it one more time. When we do that vortex, it allows a space in the middle, and it can pull the material. It can pull the material, or the water in this case, right down. I'm not sure if we can see that. All right, so this is something super fun you can do at home. And I've done it a cajillion times today because it's super fun to watch. So now I'm going to pass it. I'm not sure who's presenting next, but I will maybe remove my spotlight here and give that a shot at home.
So next we should have Jet. So he'll be hopping on here in just a minute.
Alrighty, everyone. My name's Jet, and I'm going to be talking to you a bit about volcanic eruptions today. So I'm just going to share my screen real quick. Alrighty, there we go. So we'll press the present button. Alrighty, eruptions. Got the 4 exclamation points right here because eruptions are pretty cool. Got some sick pictures right here. Excuse me. Alrighty. So what is a volcanic eruption? So by definition, it's a discharge of lava and gas from a volcanic vent. So it's like those big, huge explosions you see from those like mountain-like volcanoes. So see right here, we got a pretty cool picture. This one, it's not really as real, but it looks pretty cool, you know? You got some lightning in there, you know? Got a big explosion, nice and deadly, dangerous, you know? All those fun colors and things. Then we go a little bit further out. So this is kind of what a volcano actually looks like. It's mainly just a lot of gas in the air from far away. Unless you're like right there where it's like a sauna times 10, then you won't really see anything. But you know, the structure looks pretty cool. Alrighty, so what causes this eruption? So basically it's the heated mantle, as you can see in the right corner right here, the mantle. You don't have to read that kind of stuff, just need to know where the mantle is. So it's heated mantle, which is magma. So it's basically just molten rocks. So how does the magma create volcanoes? So basically when the mantle melts, it turns into magma. And since the magma is lighter or less dense than the rock, it floats to the surface. And usually most of this magma kind of comes to the surface in the ocean. So most of you probably know from Minecraft, when you mix water with like lava or magma, it kind of turns into a solid, so cobblestone. So this is basically what happens in real life too. So it kind of creates these underwater volcanoes like shapes and mountains. And over time, as more eruptions occur, more of these volcanoes build up and build up. So yeah, they mostly form around the tectonic plates too, which is pretty cool. Alrighty, we got some cool facts about volcanoes now. So did you know the Hawaiian Islands are actually formed from volcanic activity? So this image in the right corner is an actual real picture of a volcano, not taken by me, taken by someone on Google Images, but still, it's pretty cool. This is what they actually look like. And actually, which in Hawaii, one of the islands is currently being evacuated because there's a volcanic eruption going on right now. I don't know if it's still going on, but last I heard, it was a pretty deadly volcano. Fun fact, I was actually on the island where the volcano eruption was occurring. I left there real quick, don't worry. So yeah, volcanoes can actually affect the climate as well. So they both contribute to global warming and global cooling. So basically the CO2 produced from the volcanic eruptions, when it shoots the gas up into the atmosphere, it kind of like, it contributes to greenhouse gases and all that not fun stuff, making the world a lot warmer. But also when it shoots up the other gases too, such as sulfur dioxide, it actually cools the temperature. So something that a lot of scientists have noticed is that because of the sulfur dioxide, the atmosphere actually goes down 3 degrees in temperature. Some other fun stuff shot up into the stratosphere, some aerosol droplets and some ash from the volcano, not so fun stuff. That's why most people have to evacuate the island, because that stuff comes down. It's kind of toxic for us humans, but we just tend to avoid it. So some notable eruptions. So some famous ones you've probably heard of is the Pompeii one. That happened many, many years ago. That's before most of our times. And then the Laka Geiger, I absolutely butchered that one, in Iceland. Yeah, so a fun fact, I actually went to that volcanic eruption too. It's not really erupting, but there's all sorts of cool molten rock all over the place. Alrighty. So create your own eruption. So unfortunately, I can't show you live because I kind of want to save my laptop. And it's a little bit messy of an experiment, but I got all the clips down, all the highlights, everything you need to see. Alrighty. So what you'll need some white vinegar, an empty bottle, preferably a little bit smaller, and some baking soda, and some food coloring optional if you want to make your lava a certain color. So the first step, you want to add some baking soda to the empty bottle. I usually add about 1.5 spoonfuls, and that creates a pretty big eruption, but let's just say don't be shy and just be generous with it. Just go crazy. Step 2, in a separate container, you want to mix the vinegar and the food coloring. So I actually did this ahead of time. That's why the cap is still on the bottle. I added some food coloring. I thought it looked like lava, but you'll find out in the next clip that doesn't really look like it. So, you want to add the lava to the bottle. It's weird, the video's not showing up. Oh, there we go. Alrighty, let's see this sick clip. Alrighty, so you dump this right in. Kaboom, look at that. It's green lava, it's not really something you see in nature, but because we're feeling extra spicy, we'll make it green. Oh, no, I don't want the video. Alrighty. And then your 4th step, you want to run. So I didn't really run because I'm kind of cool that way. But I recommend you kind of run. So I got a little clip of me running right here. Doing some sprints, running away from the lava. And yeah, that's going to stop sharing my screen and pass it over to Amy, the next person.
Hi everyone. So I have a pretty fitting experiment and little demonstration considering the weather today. So I'm just going to share my screen. And this. Oh. Okay, so it's raining very, very hard out today. I actually went to the store and got soaking wet. We haven't had this much rain in a really long time, but I'm going to talk about why does it rain. So, how do I get the next slide? There we go. What causes rain? If you didn't know, rain is actually from clouds. And so I'm just going to explain very simply what clouds are. So If you've ever heard about the water cycle, this is a little picture right here just explaining it. This is a very simple version of it, but basically it's a cycle where there's clouds that have water accumulated in them. It comes out as rain, and then the rain eventually gets evaporated by high temperatures and the sun back into the atmosphere and then back into clouds. And here is just a diagram showing you how these clouds actually form. So when the water evaporates, so that means when the water is being back into the atmosphere, it needs to cling on to little dust particles. And when it does, that's what forms our cloud. And then over time, the droplets that make up the cloud, they actually start to attract even more water by the law of attraction. And so when water droplets grow heavy enough, because if you know something heavy, it's going to fall, right? So we think of gravity and it pulls them down as raindrops. And so now I'm going to show you a quick little demo that you can do at home with some things that you may have. How do I stop sharing my screen? Okay. So what I've got here is I have a glass and this is shaving cream. So if you're doing this at home, I've learned from experience, but you want the shaving cream that's very foamy, not the one that you have to lather yourself. Then I've just got a glass here and I've just dyed it with blue food coloring. And so what I'm going to do is I'm going to put my camera so you can see, but we're going to practice as if it's raining. So I've just got a little spoon thing here and I'm just going to put some water that's being added to our clouds through the water cycle. And as you can see in my glass, there's not much coming out from the bottom yet. But as I continue to add more and more water, let's keep going. So did you see that? There's some water coming out from the bottom. So as we start to add more and more water, this is making it heavier, and the gravity will start to make it fall. And this is what causes our rain. So you can thank all that rain today to all the water that has accumulated into our clouds, and it's finally has enough so that it's raining. And so you can do this over a slower process. I just kept it quick for the show, but you could also do it with a droplet and see how long it would actually take until rain is produced. I see that I have a hand up. I'm not sure if that was on purpose or not. Manel?
It's her daughter. It's a question. Isn't the water that we drink right now could have been drank by dinosaurs because the water evaporates and keeps going around and around like a cycle?
That is a theory that I have heard before. You're right. It is a part of the water cycle, and water just continues to be cycled. So that is true. That is probably water from years ago that is back in our water cycle. But anyways, guys, I hope you enjoyed that experiment and try it at home if you have the supplies. And now I'm going to pass it off to Allie.
Hi, everyone. My name's Allie, and I'm going to be talking all about thunderstorms today. So it was raining today, but there is a chance that maybe there will be a thunderstorm in the next couple days, so still fitting. So let me just share my screen. We're going to learn how to make a thunderstorm, which is pretty cool. All right. Oh, my screen is loading. There we go. So we're going to be learning how to make a thunderstorm. So here are some pictures. I'm sure you guys have seen thunderstorms before, especially since we live in Thunder Bay. Pretty common occurrence around here. So, but what actually is a thunderstorm? So a thunderstorm is caused by layers of warm, moist air that rise in a large, swift updraft to cooler regions of the atmosphere. And so the things that we can see that are results of thunderstorms are things like rain, thunder, and even lightning. And we have seen some pretty cool lightning already this year. There was some forked lightning a couple weeks ago that was pretty cool. So this is all because of a really cool property of air. So it's all about density of air. So in case you didn't know, density basically compares the mass of an object to its volume. So an easy way to think about this is if you ever have been out at camp or by the lake and you've thrown a rock into the water, it probably sank. But if you were to throw a feather into that same lake, it would probably float. That is because rocks are more dense than feathers. So it's not quite the same drastic difference, but it's the same idea. So different air temperatures have different densities. And cold air is more dense than warm air. And so that is why warm air is able to rise and the cool air kind of sinks to the bottom. So we're going to make a thunderstorm. So since warm air is less dense, it is able to rise quickly, as I said before. So once that warm air has risen, it cools and forms clouds, just like Amy was talking about, and then it starts to rain, and then the storm begins. So let's try this out. I have some pretty cool things that I've prepared. So, sorry, one sec. This is just a tub of like room temperature water. And then last night, I dyed some water blue and then I froze it into these ice cubes. So what I'm gonna do is put a couple of these ice cubes into one side of the tub of water. I got lots, so I'm gonna put a couple there. And then before this, I just put on the kettle, I put some water and then I just kept it in here to keep it warm. You can see the steam, or maybe you can't because the video is not good. And then I dyed it red. So the ice cubes are blue, that's our cold water, and our warm water is red. So already you can see, yeah, you should be able to see already, since the water that I have here is warmer than the ice cubes, you can see the blue is kind of already getting concentrated near the bottom. And so what should happen is that we should see the red rise and the blue sink. So here we go. It's not, I mean, it might not be super, oh yeah, you can see on this side, the red is going up above the blue. From my angle that I can see over here, I can tell that it's rising, but it might be a little bit trickier for you guys to see. So yeah, that's basically the same thing that happens in the atmosphere during a thunderstorm. The cool air is heavier and then the warm air is able to rise. And then that's how we form clouds and that's how we get a storm. So you guys can try that on your own if you want to use your blue ice cubes and some red hot water and make your own thunderstorm.
Awesome. Okay, thank you, Allie. So that concludes this week's science show. So we just wanted to say a big thank you for coming, and we were super happy to have you here. And our next science show will be next week on Thursday. So I'm not quite sure the exact date, but they will be at 6 o'clock every single week, and we will have a new theme. And then at the end of June, we're going to be having a big quiz night. So we hope to see everybody there, and have a great rest of your night. Bye, guys.
Bye. Thank you.
Thanks for coming.
Bye.
Thank you.
Bye.
Thank
Bye.
Bye.
Bye. Thanks, Mom.
Thank you. Then this is goodbye.
Bye, Caleb. Bye, guys.
Victoria, you look hard at work over there. Great job.